units. So this one is to find the area bounded by these two functions, and one of them is, oh no, they both have x alone. So yeah, you can probably get it in terms of x and solve for y, but I really want to get into the whole idea of doing it this way, which isn't too bad to do. Let me reposition this. Okay, so first things first, we got to find out when these two are equal to each other. So let's do that. So it's negative y squared plus 10 is equal to y minus 2 squared. Okay, and then the algebra for that is that you're going to need to distribute this one. Okay, is going to be y minus 2, y minus 2. So that's y squared minus 4y plus 4. Make it equal to 0, so I'll move everything that way. So that's y squared minus 4y plus 4, and then I have plus y squared, and then minus 10. So 0 is equal to 2y squared minus 4y minus 6. GCF, greatest common factor, y squared minus 2y minus 3. Factor this, minus 3, y plus 1. So y is equal to 3, and y is equal to negative 1. Okay, so that combined with looking at the picture of this, if we can get a picture of this, just keep in mind, you know, you see y squared here, that you know that y equals x squared looks something like this. Then y equals negative x squared looks something like this. Well, x equals y squared looks something like this. And x equals negative y squared looks something like this. So it's kind of like if you were to rotate your page 90 degrees counterclockwise is what it would look like. But you can also just put it right in your calculator and get an image of it. I do believe I did that. So let me go to plot. Yeah, there it is. And so you can see it there anyway. So that's helps too. Okay, so this one is, you got one like this and another one something like this. Okay, wow, that's terrible. Anyway, so these two values are negative 1 and 3. Okay, ultimately this is what we're looking at. We got the integral, and now it's not top and bottom, it's right. It's right function. This is the one all the way to the right, and this is the one all the way to the left. So the one all the way to the right is this one that doesn't have the negative, and the one all the way to the left, what would be quote unquote the bottom function, is this frowny face one. Okay, so so this is going to be y minus 2 squared minus negative y squared plus 10 dy, and this is from negative 1 to 3 because these are y values. Okay, this is y is negative 1, y is 3, all y values, dy. So when you put this in your calculator, I will put this in my CAS side. Let me see if I did, yeah, delete. Okay, so I did put it in. I had initially typed it in wrong, and then I have enter. Oh, 9/2, right. Okay, it can be done algebraically, but like again, I said, I'm just focusing on the concept right now. Okay, and oh, notice when I put it in my calculator, everything's in terms of x, because they have variables here, we just have to just put it in terms of x so that we can compute it. Okay, determine the area of the region bounded by these two. So, you know, try this before I do it. Pause this if you have to, and try to sketch this on your own without your calculator. Of course, you can use your calculator, but this is a problem you should be able to theoretically do by hand. But whatever, just give it a go. I mean, you can set them equal if you want, but sketch it. Try and do this without waiting for me to do it first, okay? Okay, so I already have x equals. I like to put it in this order, okay? And now if I get x equals over here, this would be x equals y plus 2. If I set them equal to each other, y squared equals y plus 2. Y squared minus y minus 2 equals 0. Y minus y minus 2, y plus 1 equals 0. Y equals 2, y equals negative 1. Okay, so when I sketch this, we are looking at this parabola. Remember, it's not going up, it's going sideways. It's irregular, but it's sideways. And for the line, don't try and do that line backwards. I mean, this is so much easier to just look at it how you know, like the y-intercept is negative 2. And then the slope is 1, so it's something like this. Now, when you do your integral, what is the top function? So what is your right function? Because everything's in terms of y. Everything's going to be here. This is going to be dy, right? I know it's going to be dy, so I know these have to be y values. As such, I have here, so it would be negative 1 to 2. I know it's not like it changes at any points. The whole time it's a top, bottom, top, bottom. It's always this line on top and always this parabola on the bottom. So I know my top function is going to be the line, and my bottom function is going to be that parabola, dy. And there it is. And you can just probably put that right in your calculator and get 4.5 or 9/2. Right? But you could also do this one by hand. It's really not that much to do. But like I said, you know, you get the antiderivative, you plug in the 2, you plug in the negative 1, fundamental theorem of calculus, subtraction. It is good practice. But we have a lot of problems to do, so I'm just going to focus on the concept, okay? So. All right, so now, I have another copy of it. So, do I? Okay, so now let's take a look at how this would look. For this one, it says determine the region bounded by y equals 2 cosine x and y plus 1 equals x squared. So it's just bounded by these two graphs. So let's get an idea of what this looks like. Cosine x starts at the top and it goes down, and since the amplitude is 2, it does something like this, right? It goes back up. This is like this too, right? And then this is y equals x squared minus 1. Minus 1, and it's x squared. Not exactly sure where these two guys intersect, so I would have to put that in my calculator. So, yeah, you go over here, you put it in. I can just use the regular function now at this point because it's in terms of y equals, so I can do that. All right, and then you just put them in to cos x. I am in radians, good. Make sure you're in radians in case you had physics going on. And then x squared minus 1. Okay, so now we're going to go to plot. There we go. It's kind of like what I have. And the reason I'm doing that is I need the intersection. So I'm going to go here, menu, function. Now here's an important part. I'm going to get to the intersection. Yeah, I want that. And it tells me what the intersection is, and I'm going to need to store that. So we will need that x value. So I'm going to put it here, and I'm going to call it A, right? And I'm just going to do it there because it's simpler. And then down here, I'm going to just say A to the reader. When, you know, you have your AP of the reader, and you just say what A is, and it's negative 1.2654. And over here, I'm going to put B, and I'm going to compute what B is, which is probably symmetrical. And it's going to be positive 1 point, but we can make sure of that. Okay. I actually don't remember if it does that. So we'll take a look. So over here, I want to store this. Remember, I told you I did want to store it. So I go to, you see how it says here, copy. And, oh, sorry. It says here, it's hard to see, but it says in blue, copy. So since it's in blue, you have to press Shift, copy. And it says here X, and you say, yeah, I want the X value. Okay. So it stored it. So if I go to my main screen here, and I clear that for a second, and I just type in X, it's going to be that value. All I did was type in X. So it knows that that X value is that, or I can do paste, second paste. And it will ask me, oh, do you want that negative, you know, that value there? And you just say enter. So either one, okay? All right. So anyway, so I'm going to keep that value, and then I'm going to go to the next one, graph, plot. Here we go, menu, function, intersection. Okay, and lo and behold, it is the same value, but it is the positive version. Didn't see that coming, right? So, okay, so anyway, it's top minus bottom. So, come back here, and it's the integral. The top function is my cosine function. The bottom function is this one. I'm going to make a mistake. And hopefully you catch it. The mistake is I should have put parentheses because that's a binomial. And then you don't make the mistake. Okay. And then this is dx because these are all in terms of x. And the x values, you are allowed to write a and b as long as you say a and b over here to the reader. And then you just say what the answer is by plugging it in. So you go back to your calculator. You can go to either one. It doesn't matter if you go into CAS or the other one. I like it when I know it's going to be a decimal answer. I like to, and with cos, you can pretty much suspect it will be. I like to go into this one because I don't want it to give me some crazy thing. I like to go into the house side, okay, the home screen. Okay, so here I am. I'm going to go into here, and it's that value over there, but let's say I didn't have that yet. I would go to second paste, enter. I forgot to store the top one, but I know it's the same thing. Enter, but without the negative. Okay. And then over here, I can either just type it in because it's so easy. 2 times cosine x. Minus parentheses x squared, x squared minus 1 dx, and there, enter, and that gives me 4.9949. So I'll just say that's 4.995. Okay, technically you can just make it 4.99 and just drop the 4, even though that's a 9. Just drop the 9 and write 4 there, which drives me crazy. That's called truncating, but the AP allows it, strange as it is. All right, anyway, so back to this. So now we have this one, determine the area of the region bounded by these two. So definitely can get y alone, so let's do that. So y is equal to x cubed minus 4x squared. Y is equal to 2x minus 1. I'm going to try and see if I can set these two guys equal to each other, right? So that's 2x minus 1. I had a calculator, I would just type that in my calculator and find the zeros of it. If I can